Hey, I'm Hunter, the founder of Regatta Storage, and I'm excited to show you a little bit about it today. Regatta transforms S3 buckets into unlimited local file systems that provide instant access to massive data sets in S3. Regatta is a high-speed caching layer that sits in between your EC2 instance and your S3 bucket that allows us to efficiently perform all POSIX operations on the bucket with low latency, even those that aren't possible on S3, like directory renames. Let me show you a file system. This is the Regatta console. And as you can see, it's connected to a bucket called Regatta Demo Bucket. This bucket is in AWS, but we support any S3 compatible storage system to synchronize to. If we look at that bucket, you can see that there are some files and folders in it. To connect to your file system, we use IAM authentication. So when you mount from EC2, you don't have to manage API tokens. You just tell us right here in authorized users what the EC2 instance role of your instance is, and we take care of the rest. Connecting to Regatta is really easy. It's just a mount command. I'll show you that this folder is not mounted now, and we'll go ahead and run the mount. We provide a custom client because today Regatta is exposed over NFS v3. And in order to do the IAM authentication and also encrypt data through a TLS tunnel, we have to wrap NFS with our own client. Now if I look at that folder, you can see that it has the same files and folders as my S3 bucket. Let me show you a little taste of the performance of Regatta. So let's run an FIO workload here. And let me show you what is in that FIO workload. So it's super simple. We're doing 1 megabyte reads to 64 megabyte files. But what I want to highlight is that there's not a lot of parallelism. We're running 8 concurrent jobs with an IO depth of 4. And with just that, you can see we're able to get 1.5 gigabytes per second of throughput, which saturates the network card of this instance type. It's the same situation with writes, and our single instance IOPS are also around 10,000, both for reads and writes. Now, this is all great, and I know that you're excited to use Regatta for applications that need real file semantics, like random writes in the middle of files, directory renames, symlinks. We support all of that today, but I want to show you something you probably haven't seen before. If you're familiar with NFS, you may know that taking an application that's running on a local disk and moving it to NFS experiences a performance degradation. Generally, this is because these kinds of workloads operate on lots of small files, and NFS as a protocol is designed to safely handle concurrent writes to individual pieces of data. Because of that, it has to constantly revalidate with the server its state of the world, and it has to do those round trips on every file you touch. We've found that many applications don't actually need this functionality. For example, workflows might run at one instance at a time, but they want that data to be passed along, and they don't want it to be stored in a very expensive storage tier. We're building a protocol that optimizes for these single reader, single writer cases. Let me show you a little bit about what that looks like. So again, you'll see that the test directory is not mounted. And we'll run our mount script, which is different this time. Now we're running through a fuse layer. If we take a look in that test directory, you can see that it matches a different S3 bucket that I've mounted called performance testing. But one of the tests that we would do to evaluate these small file workloads is actually untarring the Linux kernel. This is probably something you've never noticed before, because if you do it on a local disk, it only takes a couple of seconds. But if you try to untar Linux's source code, which contains tens of thousands of files in it, on an NFS file system, it can take 10 to 30 minutes. And in fact, I tried it this morning on an FSX for ZFS and got about 10 minutes. And that shows you just the scale of degradation that people are used to when they think about these file systems. But as you can see, our protocol is able to do it in just 11 seconds. And what's cool about this is because Regatta is synced to S3, you can actually see that Linux's source code has just been placed in this S3 bucket. Now, it might be kind of weird, but maybe you're running a CI/CD service and you don't want to keep these artifacts on hot storage. You want them to go to S3 so that you're taking advantage of the low costs. I'm really excited about Regatta. I hope that you're able to leave comments with feedback or ideas for direction, and maybe even try out the service today. Thanks.